Hello students, welcome to SOURAV classes. Today we'll be solving the part 1 of TIFR Maths question paper of year 2017. We have solved question numbers 1 to 25 in the earlier videos. Today we'll be solving question number 26, 29 and 30 from the same paper. So let's begin with question number 26. In question number 26 it has been said that suppose A1, A2 up to AM are distinct n cross n real matrices. Distinct n cross n real matrices such that AI into AJ is equal to 0 for all I not equal to J, and in that case we have to show that M is less than equal to n. We have to check whether this statement is true or false. So let's begin. Let us take some general matrices for the sake of simplicity. Let us consider three sets. Let us consider three sets A1, A2, A3, which are 2 by 2 matrices. So A1, A2, A3, and these are all 2 cross 2 matrices. So therefore here M equal to 3 and N is equal to 2. The matrices A1, A2, A3 can be taken as A1 is equal to 1 0 0 0, A2 can be 0 0 0 0, and A3 can be 0 0 0 1. So A1, A2, if you multiply A and A2, we get 0 0 0 0. So we have to basically find those matrices, the combination of those combinations whose multiplication will lead us to a null matrix, as has been indicated over here. So A1, A2 gives us a null matrix, and when we again multiply A2 and A3, that will also give us a null matrix. Actually, any null matrix with a null matrix, that gives us a null matrix. So basically, if null matrix, and also when we multiply A1 and A3, and that also gives us a null matrix. So basically, in that case, we are getting null matrices for these three combinations. So basically here, even though M, which is 3, is greater than N, which is equal to 2, even in this case the condition that has been given has been satisfied. So the assumption that M has to be less than equal to N is false. So the assumption that M is less than equal to N is false. Let's solve the next question, which is question number 29. In question number 29, it has been said that let yt be a real valued function which has been defined on the real line such that y dash is equal to y into 1 minus y, with y0 belongs to the closed interval 0 to 1, and then it has been said that the limit yt as t tends to infinity is equal to 1. We have to find whether this statement is true or false. Let's find out. Now it has been given that y dash is equal to y into 1 minus y, and also y of 0 belongs to closed interval 0 to 1. Now y dash is equal to y into 1 minus y, so this y dash is nothing but dy dt, since y dash is a function of t. So dy dt is equal to y into 1 minus y. So if we do some adjustment, then will come now dy is equal to dy by 1 minus y is equal to dt. So now if we integrate this thing, on integrating, we get integration dy y into 1 minus y is equal to integration dt. This gives us one by y plus 1 by 1 minus y into dy is equal to dt. So this implies log of y plus log of 1 minus y is equal to t plus some constant c. Now if so at t equal to 0, when t is equal to 0, we get log of y plus log of 1 minus y is equal to c. But we do not know the value of c, so we have to find out some value of c. So if y naught is equal to y of 0 is equal to half, we can take y0 is equal to half, since it has already been said that y of 0 belongs to the closed interval 0 to 1, so we can take some value of in between 0 to 1. We are taking the value in between. So if y0 is equal to 1 by 2, in that case this line, this comes down to log of 1 by 2 plus log of 1 by 2 is equal to c. This implies 2 log 1 by 2 is equal to c. So this implies c is equal to 2 log 1 by 2. So now we can write that from this statement we can write that log of y into 1 minus y is equal to t plus c, and this implies that y into 1 minus y is equal to e to the power t plus c. So as t tends to infinity, y into 1 minus y also tends to infinity. Since as t tends to infinity, t plus c tends to infinity, and e to the power infinity tends to infinity, so this overall statement tends to infinity. So if this is the case, in that case we can write that the limit y of t as t tends to infinity does not tend to 1, and the statement that limit yt as t tends to infinity tends to 1 is false. Now let's do the next question, which is question number 30. In question number 30, it has been said that the matrices x0 0y, x0 0y and x1 0y, where x not equal to y for any xy belongs to real number, are conjugate in M2R. Let's do it. So it has been said that x0 0y and x1 0y are conjugate in M2R. Are conjugate in M2R, where x is not equal to y and for all xy which belongs to R. These are the conditions. So let us assume another matrix ABCD, and if let us ABCD is a matrix, 2 by 2 matrix, compatible for multiplication with this given matrices, and if this the x00y and x00y and x10y matrices are conjugate to each other, in that case we can write that x00y into ABCD is equal to ABCD into x10y. This is from conjugates, from the fact that the matrices are conjugate. Now we multiply these two sides. On multiplication, it comes down to XA, XB, YC and YD. This is equal to AX, A plus BY, C of X, C plus DY. Now we equate both the sides, and when we equate, we can derive the following conditions, that bx is equal to a plus by. This implies b into x minus y is equal to a. Now x is not equal to y, so this is not equal, x minus y is not equal to 0, so we can definitely take x minus y downside, so we'll write b is equal to a into x minus y. Also, there is one more condition. If we equate these two terms, then it will be giving that yc is equal to cx. So if we bring all the terms to one side, then it will be c into x minus y is equal to 0. Now x minus y is not equal to 0, so if c into x minus y is equal to 0, then definitely this implies that c is equal to 0, since x minus y not equal to 0, since x is not equal to y. So after finding all of this, we can see that the matrix A, B, C, D will take the formation of 1, 1, x minus y and 0. So this is a real set, and we can therefore conclude that the matrices x00y and x10y are conjugate to each other in M2R. So we have solved question number 26, 29 and 30 from this paper. Thank you for so we have solved the entire question paper of TIFR Maths question paper of year 2017 in this video. So along with the earlier videos, if you watch the earlier videos and this video, we have completed all the questions from the said paper. So thank you for watching SOURAV's classes and SOURAV's videos, and all the best for the upcoming exam. Thank you.